Hello everyone, welcome to Learn at Scholar. I'm Geeta Khatri. I am here with your new chapter, linear equations in two variables. Till now we have been discussing linear equation in one variable, right? So now we will discuss linear equations in two variables. It may be x and y, y and z, a and b and more. Many situations in real life arises where we need to find two variables. I am giving you one example. Like one person goes to the market to buy some fruits. You have been told by your mother to buy bananas and mangoes. You have bought the mangoes and the bananas, but you have forgotten how many kilos are there of mangoes and bananas. So you have to find out the number of kilos, and some data is available with you that like you remember how many rupees per kilo that vendor was selling, and you remember the total amount that you paid to the vendor who was selling the fruit. Like bananas were 40 rupees per kilo and mangoes were 100 rupees per kilo, and the total amount that you paid was 360 rupees. So the equation will be like this: 100 into x, that means x kilos. X is the number of kilos of mangoes that you have bought, and y is the number of kilos of bananas that you have bought, right? So the one equation will be 100x plus 40y is equal to 360. That means 100 rupees per kilo of mangoes, 40 rupees per kilo of bananas, and total amount was 360. So this is one example of linear equation in two variables. There are two variables x and y, right? You have just used that data to form the equation. Now the second equation will be the total kilos of fruit is 6. So x plus y is equal to 6. So you can easily find out the value of x and y by solving these two equations. And you will be able to know the exact kilos that you have bought of mangoes and of bananas. Now you have understood why do we need linear equations in two variables? You will have to form the equations based on the given data. You will be given some data. Some data is missing. Like in the previous example, we had to find out the exact kilos of mangoes and bananas. In the same manner, now we will be given some data and we will have to find out some unknown data. And this unknown data will be in the form of two variables. We will solve the two equations and we will be able to know the unknown data or the unknown variable. You are going to solve these type of questions in this chapter. If you want to watch all the videos, do like, share and subscribe the channel.
Like, share, and subscribe.
Do not forget to press the bell. Then you will be able to receive the notifications whenever I upload the video. Now we are starting the chapter number 3, linear equations in two variables. Now there are three types of pairs of linear equations. Linear equations, that means the graphical representation of that equation will be a straight line because it is a linear. Linear means line. So the graph will be a line that can cut x and y axis, right? In the second chapter, we have read that where the line cuts the x axis is the zero of the equation. You remember? Yeah. Now, if there are two lines and if they are cutting at one point, that point will be the zero of both the equations. Understood? You will understand this is a graph and this is a line of one equation, this is the line of second equation, and this is the intersecting point. So these two lines are intersecting lines. And this is the unique solution of two lines, two intersecting lines. And the second pair, if there are two lines which are not intersecting and are parallel to each other, these equations do not have any solution. So these pair of equations are called inconsistent because they are parallel and they have no solution. While intersecting lines have unique solution, so these pairs of lines are called consistent, right? There is third pair where the two lines coincide with each other like this, means they are coincident. One line is this, another line is just above the first line. So there are infinitely many solutions of these equations. Like we are solving one question, and we have been given two equations. When we try to solve these two equations, we will be having many solutions. That means many values of x and y that are common to both the equations. So these equations are called consistent and dependent. Understood? This is all that I have just explained. You can write in your notebook, and if you want to remember all these things, you need to solve a lot of questions, practice, so that all the data will be incorporated in your mind forever. Maths needs practice, right? Without practice, you will not be able to remember all the formulas, all the details, and all the facts that are given in your maths book. So I will be solving important questions in the view of your board exams. I have solved many questions that are important in the view of your board exam. You can watch those videos. The links are also given in the description box. If you want to watch all the videos that I am going to upload, you need to subscribe the channel and press the bell and press all. Then you will be able to receive notification whenever I upload the new video. So this is all about the pair of equations. One is consistent, where there is only one solution, that is a unique solution, and the lines are intersecting. The second type of equation is parallel, where there is no solution. The pair is called inconsistent, and the lines are parallel in the graph. The third pair of equation, where the lines are coincident, that means they are one above the other. This pair is called consistent and dependent, and there are infinitely many solutions. Now, if you are finding out what type of equations are these, then by using the coefficients, you need to find out first a1 upon a2 is equal to b1 upon b2. If they are not equal, no need to find out the value of c1 upon c2, because if they are not equal, that means the pair of equation is consistent and you will be having a unique solution. That means the lines are intersecting. Okay, if they both are equal, then you need to find out the pair of c1 upon c2. If a1 upon a2 is equal to b1 upon b2 but is not equal to c1 upon c2, then you will get a pair of parallel lines. If it is equal to c1 upon c2, then you will get infinitely many solutions. Have you got my point? Now I am giving you some examples.
The two equations given are 2x plus 5y is equal to minus 11 and 4x plus 10y is equal to minus 22. This is a pair of linear equations in two variables. You can just change these in standard form, or you will direct write a1 upon a2. The value of a1 is 2 in the first equation and a2 is 4 in the second equation. The value of b1 upon b2 is 5 and 10, and we will reduce the fraction in standard form and we'll get 1 upon 2. c1 upon c2 minus 11 upon minus 22. Minus will be cancelled and we will get 1 by 2. So you can see that a1 upon e2 and b1 upon b2 and c1 upon c2 all are equal to 1 upon 2. That means they are equal. And what does it mean? Yes, in the pair of equations, when plotted on graph, will be having infinitely many solutions. So the graph will be coincident. That means the lines will fall one over the other, right? So these all the inferences are given by the coefficients. The third result is the pair of linear equations is consistent. That means it has at least one solution. We know that the pair of linear equations in two variables will be consistent if and only if it has at least one solution, either unique solution or infinitely many solutions. The equations should be converted into standard form first. That means a1, b1, c1 and a2, b2 and c2 will lie in on the left hand side of the equation. 2x plus 5x plus 11 is equal to 0. 4x plus 10y plus 22 is equal to 0 is the second equation. The result is consistent and dependent. Now we will move to the second pair of equation. This is the second pair. So we will see the result. We will observe a1 upon a2, b1 upon b2 and c1 upon c2. a1 is 1, a2 is 5. So we will write a1 is 1 and a2 is 5. Now b1 upon b2, minus 4 and minus 1, 4 upon 1, c1 upon c2, minus 14 and minus 13 is equal to 14 upon 13. So we can observe that a1 upon a2 is not equal to b1 upon b2. So we don't need to find out whether it is equal to c1 upon c2 or not, right? The pair of equation has a unique solution and the graph will be intersecting. And what else? The pair of equation is consistent. Understood now? The equations were already in the standard form. We will move to the third pair of equation now. The pair of equation here also is in the standard form. So we will directly find out a1 upon a2, which is equal to 1 upon 3. b1 upon b2 is equal to minus 3 upon minus 9 will be equal to 3 3 ja 9, 1 upon 3. c1 upon c2 is equal to minus 3 upon minus 2 is equal to 3 upon 2. So we can easily see that a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. Now pause the video and find out the inferences yourself to check your understanding. So the inferences will be the pair of linear equation in two variable will be in the form of parallel lines and it will not be having any solution. The lines will not meet anywhere. So the pair is inconsistent. Now you have understood? Now I am giving you one question to solve. Solve that question, draw the inferences and write in the comment section. This is the question of the day. X minus 3y minus 7 is equal to 0. 3x minus 3y minus 15 is equal to 0. So find out the ratio of the coefficients and draw the inference. If you have any confusion, any doubt, any query, you can write in the comment section. I will solve that doubt and reply. You need to find out the type of equations, that means consistent or inconsistent. Then what type of graph will it be? Intersecting, parallel or coincident? Solution, infinitely many solution, no solution or unique solution. Understood?
Have you understood now? The concepts are clear to you? If you like the video, do like, share and subscribe the channel to watch more. Bye-bye.